and I'm very happy to see you here today at Tech Tuesday and Go to 10 or Go to 10. Go to 10 is a new meeting place in the Science Park. It opened for just more than a month ago, and it's an open meeting place for events like this, but also the ability to come here and work with their podcast studio and everything. So I hope to see you here more times. And about Tech Tuesday is a collaboration between 5 different companies. It's Sectra, Ericsson, Mira Dynamics, SIGIVP, and Combitech. And these companies are hosts for a meeting each. And today we are here together with Boan Johansson from Ericsson, who will talk more about the cloud. I think there's like a bit of a theme this season. We have a lot of Tech Tuesdays talking about cloud, and I think it's really interesting to see it from different companies' perspectives. So today it is we have Ericsson.
It's not mine. Det är inte på min, tycker jag. Jag kan liksom inte klicka på. Jag hovrar under den.
Yeah, so today we have Anders here talking about high performing cloud and embedded software. Anders will talk about 30-35 minutes, and after that we have time for questions. So please save questions and we'll take it afterwards. We also have some participants at Zoom. That's why this box turned up over here. And we will record the meeting as well, so you know that also during the Q&A in the end.
Ja. Thanks for the tip.
So
finally,
Anders, I leave the floor to you.
Yes.
Welcome, Anders.
Yep. Thank you. So yeah, like I think many of you know, there are great possibilities with cloud technology, but there's also a fair amount of buzzwords out there, and many of the concepts are not really so new. I mean, there's a lot of common best practices that's been around for decades. And it's also so that not all problems are solved in a pure cloud native way, even if that's something that most companies want or need to be, they think at least. But this talk is a bit how to balance the different aspects, like how you get high performance, and you also have high feature velocity and other kind of characteristics that you want from or need from your software. It's also so in an ongoing energy crisis that it's never been more important that we also are efficient, even if we are in a cloud environment. I often hear that it's more, yeah, just throw more hardware at the problem, sort of, and that's how you solve all problems, especially in a cloud deployment. But I'm sure that the greenest software stack will be a game changer in the long run, and I think we will see much more focus on these kind of aspects also in the near future. And yeah, as I've been introduced, my name is Boan Johansson, and I work at Ericsson as a technical leader, but I still work as a developer. So besides doing more high-level stuff like this and more architecture stuff, I do a lot of troubleshooting and characteristic analysis. So I'm not so much in the middle type of software development, in feature development, so I'm more in the extreme ends. And at least for me personally, I think that's the only way I can stay relevant with technology, by being down in the details. If you ask management consultancy firms like McKinsey or Arthur D. Little how they would characterize the top tech companies that have really succeeded over the last years, they would say something that it's those that have been adopting to cloud native principles using AI, ML in a DevOps setup. That would be sort of the answer that they give you. And it's equally true that those companies that have forced in not suitable applications have failed miserably, and it actually cost them more, and they're bleeding money compared to before they did a cloud transition. And this is my favorite Dilbert strip. I'm not sure you can read it, but it's when the point you had manager comes and asks Dilbert why not all problems just magically went away when moving to cloud. And Dilbert answers that, well, you didn't let me re-architect the application to be cloud native. And then he just keeps saying, just put it in containers, Kubernetes, and those kind of things. So I'm not sure if I've met this exactly with customers, but I've definitely heard it internally in discussions with managers. It's a bit sad. I mean, it doesn't help. Just putting things in containers doesn't really help. Well, it can help some problems, but it's not. You don't get to be cloud native by just doing that, at least. And I think this emphasizes that you need to understand why you're moving to the cloud and what is your driver and what problems do you want to solve with it. I think that is key. And there can be many different drivers for this. It could be that you want to use cool technology, or that you heard about DevOps. That's a great thing, and or that you want to decrease your feature lead times, for example. That's usually a big driver, at least for our customers at Ericsson, and that is they want to move in this space because they have seen things like McKinsey and others say that those companies have been more disruptive and are doing great, and they are more innovative. But utterly, they want to get features out to the market in a faster pace. That's why they want to have vendors that are delivering those kind of products. At Ericsson, we have a huge install base of lots of hardware. I mean, Ericsson, even if we are a big software company, it's still a lot of hardware. I mean, that's what you make a lot of money from. So when moving into this space, like I said, we have been at this now since, I think 2014 was my first, when we started to do our first projects just here in Linköping that were aiming for LTE, for 4G, doing cloud applications. That was more than in VMs and bigger applications. And then we have done a number of iterative steps since then. But one thing that is a bit problematic here, when you have a lot of hardware and software out there in the networks and they work and you operate them in a certain way, it's sort of, even if our customers want to have something new and disruptive, they still want to have the same kind of look and feel, and it feels nice that everything is working exactly the same as it always have. So what they often come back to is that it's not only enough to come with a new product that has sort of feature parity and that is equivalent in some way. As soon as it starts to differentiate when it comes to how you operate it, what kind of counters you can see and so on, then that gets to be a problem. So what they really want is that it should be actually the same source code, and then also that it should behave in the same way. And that this is something that we have been up against so many times. And maybe I should say so also that we are targeting a lot of to be as agnostic as possible for which kind of underlying platform or hardware that we're using, just because of the fact that our customers in the end, they have chosen OpenShift, for example. That's a Red Hat distribution of Kubernetes, and that is something that many big customers have chosen. And then there are plain Kubernetes installations and VMware or whatever. There's the whole palette of different hardware and technology on top of that, and we need to be agnostic to that. Not that being said, we still have a few systems like how we that we do more mining on, data mining and pulling out PM, fault management, and so on. That are typically services that are suitable maybe to run on some of the hyperscalers like Azure or Anthos or whatever. So we are looking into that also. But what the applications that I'm speaking mainly of here today are things that you could basically run them on any type of server, or you can run it on any kind of cloud provider also. Think of it as a Kubernetes orchestration point of view with containers and so on. That is the current focus. But we are sure that there will be other things coming in the next years. So it's not, you can't bet on the one horse. I think there are quite many companies that are starting to use cloud technology that are for specific vendors or suppliers like Amazon or so on. I mean, you easily get into a lock-in situation where you need to continue to pay their their money also in the long run. Hopefully, we will not get there. So typically, our customers manage their own networks. They have that kind of workloads for other kind of businesses and yeah, other types of workloads already today, and they want to incorporate the telco stuff in there also. So when we're talking about these kind of services, think of it as applications that could run on a Raspberry Pi, for example. That is the kind of, you can't be embedded like down on ASIC level or so on. I mean, we are doing that kind of very low level stuff also, but the kind of services that I will mainly talk about now is typically control plane functionality, things that have a semi real-time characteristics. So again, think of it as Raspberry Pi all the way up to the worst server that you can think of. And if you ever plan to get to something like Canary Upgrade, which is a concept within in cloud native, that you should have a different life cycles and be able to do A and B testing in live networks and so on, it all starts with interfaces. That is the key enabler here. And preferably you should have something that is version handled, backwards and forward compatible, working over some kind of IP networking. And this is no real difference here if you do an application that is running on your Raspberry Pi or in another system. You might have or communicating with many different instances of it also. So it's not just one single board perhaps. And then of course that makes sense to have that kind of interface handling. So this is something that we have focused a lot more ever since we started to realize that we need to do something that is very deployment agnostic. So it should possibly be able to run everywhere more or less. We're using a lot of Google protocol buffers on top of TCP/IP, but there are other examples like gRPC or REST API. So it's typically the way that you solve everything in a cloud native evangelist way. But I would say that it would be really crappy systems if we use REST APIs for everything. But so not one size doesn't fit everything. Another such aspect, which I think is key to surpass, is also the fact that you scale in the right way, and that is scaling by processes or process instances. Or if you have something like, if you have a Java applications, then you need to think of it as you should instance your JVM, which also makes it a bit harder to use things like something as a virtual machine inside a microservice. But not take the easy way out and scale with pthreads, for example. What we want is to have something that you can create new instances of, and you can get the resilience. So if something crashes, you shouldn't be tearing down the whole thing that you would if you just used more or less threads here to utilize more or less CPUs. Another thing is there is often talk about that the size of the problem needs to be fit for the size of a 2-pizza team, and that's typically then 6 by 2, so it's a 12-person team, and that's nice if you can always define your problem to be that large. But if we take something that is defined by standardization and so on, you have certain there's a certain ballpark where you can move here, and we have such applications also that are quite small and can fit in one team. But there's also huge ones that have many times more than this. And still, if you would to take that and split that up so it always fit into a two pizza team, it's you're going to expose more interfaces. You're going to maybe add even more states to your application. So of course, it needs to be the division of concern that must rule here. Another thing is also how performing your software is, and that goes the same for even if you do an embedded application or if it's a cloud application, it's equally important. I was a bit surprised when the first time we came up with we're doing our first cloud deliveries, and the first thing that the SPM or the strategic program manager asked us was how many cores we can run this on and how can we beat our competitors here, because for the first time we can actually compare the software implementation side by side, more or less. It's the same hardware, so now we can really do a diffing here on the capabilities. which is maybe a bit easier to get away with on embedded deployments. So again, not really a difference here between a cloud or an embedded deployment. Here is another aspect of this, and connected to the trending of doing environmental friendly applications also. In this case, here's two imaginary implementations of the same thing. So it's the same feature. It was just implemented in two different ways. I can bring up the next one also. So the first one, the red one here, it took some shortcuts and was a bit faster in time to deliver. And that's something that is good for our customers. I mean, they really quantify time, how long it takes for us to get to the market is something that is in money for them. So if it takes longer time, that would be a loss for our operator. And it will also maybe potentially take longer time for us as when implementing, we will have man resources more put into this. So that will also lead to extra cost. But if you look in the long run, if it's something that adds too much cycles, that it's something that is quite inefficiently used, and we just throw hardware at the problem like we normally do in a cloud, then the total diff would still be higher. So the loss for the operator would be greater in this example if we take an easy way or we get faster to the market, but we get higher cost over time. And this is something that we actually have defined a thesis work for, that this has been quite popular to have this kind of comparison between the investment and how much time you should spend on maybe performance analysis and optimized software also for cloud deployment before you take it out and make it cost on the same thing on millions of nodes out in the world. So cloud native, if we take three of the top areas here, which is designed for resilience and statelessness, and also designed for automation. We talked about canary deployment before, and also how we scale, and that's great. That's sort of a boilerplate that you need to have elasticity in the cloud, meaning that you should not only scale out, you need to be able to scale back in when you don't use more, if you have resources that you need to rebalance in your network, whatever. But it's not only that. In a cloud deployment, we often have a completely different availability that what you're compared to, or what you can compare to at least in a telco setup. We are used to have KPIs saying that it must never in average be below 5 nines, and that means something like 5 minutes per year for every node that we have out in the field. There's an average downtime of 5 minutes in total, and if it goes below that, then that's a red flag, and we get a lot of phone calls then from angry managers, and we stay below that. And if you take in a cloud infrastructure, then it's not uncommon to have something like only 2 nines, that you like 1% of the year there's some kind of downtime or something that is moving around, and that's something that we need to be able to compensate here with resilient applications. So we might not be able to improve that kind of availability, but we need to have applications then that can move around between different data centers or internally in the data centers. And I think this is for sure. I mean, this is nothing new. This is the same for all types of applications that need to have a certain availability. But it's something that is still not really solved. Even if you add things like geo redundancy and so on, it's still going to have a quite large impact. So this is a complicating factor for sure, and something that we're working a lot with. The other aspect of be stateless, and that's something that has, I think, shifted a bit over the years. It used to be, or if you're a cloud native sort of religious in that sense, that then you can only solve things and you need to be completely stateless and so on. But how many applications out there in the world is completely stateless? Not many. And that's especially not then if you have something that is defined by standards and so on, that you can't really change. Yeah, some applications they are defined in a certain way, so you can't really change that unless you rewrite everything and rewrite the standards also. In this example, it's just an illustration, even it's very hard to see on this screen here. It's this is an illustration of just a one setup chain for one user in 5G. The interaction with the user equipment handling, which is a very central part in NR. And if you look at this, it's something like 200 in and outgoing messages. So that you can compare it to like a web request, which does lots of database accesses, and you look up things everywhere. So just to be able to set up and in this case also release one user, it's a lot of interaction here. And of course you can do this if you were to just take this and externalize the state here. And in each and every of those, you actually need to check something, that is this something that is you should be able to do this, or is something that should be directed or so. And if you externalize this, which is a common technique, to a Redis database, for example, or some other database, that would then add quite a lot of latency to every such procedure, which is really a time-sensitive procedure. But you can do something that is in the middle ground, that you split things up in parts here, and that you let one instance run one thing at a time. That would be one way. So you can externalize a few items of them. So there are still techniques that you can use to even have something that is very stateful. You can still move it in a way so you reduce that kind of dependencies. And of course, you could think that we can run everything in parallel and so on. But unfortunately, almost every step here is a refinement, or you coordinate with and you get more interaction with the UI or the mobile device, for example. So unfortunately, there is a lot that needs to be done in sequence also. Hence the need of have a state. So you need to sort of accumulate all the data that you gather. Designed for automation. I think here is the biggest enabler, or the biggest gain that you can get from the cloud native world. I do a lot of open source projects myself, build a lot of IoT devices, and so even if I do things on this at work, I still go home and relax with building more stuff. That's what I love. I think that over the last 5-6 years, I've gone over to more or less do everything in containers. So even if I'm going to do something that runs on a Raspberry Pi, there you can run container environments. But also, even if you build for something that is highly embedded, I still have the development environment, or my Python setup inside a container. I never do anything raw on the machines anymore, because it just saves you so much time. So I think, in this space, I think I really try to inspire everyone that hasn't tried it to really go for it, because it saves. I can feel it, how it saves time every time I use it, and I think that is a big takeaway for me. Ericsson at least have worked with CI, continuous deployment, CI loops, and so on for a long time. I mean, that's in our DNA, but I would still say that there is still huge potential there, and we're still quite far away from this kind of DevOps setup that many talk about. And DevOps, as the name says, sort of that it's to bring developers and the ops people, or the operation guys, closer together, and preferably to be at the tip of the finger of every developer, that you should be able to run and get a good quality stamp on your software before you deliver something, and maybe all the way out, especially if you have something that is set up to be canary deployment, that you just send a fraction of all the customer traffic out to this new piece of software that you have just delivered. And okay, it goes down, but what's the harm in that? So that kind of feedback loops are great if you can get that set up. And we're getting there, but I think here we have much room for much more innovation. Something that I think is key here also when talking about automation and development experience and efficiency is that it's becoming more and more vocal that companies that are working continuously with development experience and invest in the tooling, IDEs, build environments, etc. They are the ones that are more successful than those that are quantifying everything, that you want to have a KPI before and after to see what was the gain when we introduced this new way of working and so on, sort of measuring on everything. But it's rather the ones that are just continuously, without really asking why or how much, continuously investing and involving the development environment. They are the ones that get the best feature throughput in the long run. And I think that's something that is very nice as a developer to hear that. And that's something that I actually start to hear the higher management talk about those kind of things also. So it's starting to kick in. On that same sort of subject here with development environment and so on, choice of language is one aspect of that. I'm a big fan of choosing the right tool for the job, for sure. Even if we don't want to end up with a mess that we're allowing maybe 20 different programming languages and 5 different build systems and so on. I mean, that will create another type of mess also. But in the same way that we looked at energy efficiency versus the time it takes to develop a feature, I think, and this is also a thesis work actually, to be able to quantify this in a way that we have some tools here. Don't matter so much how I put them out here. It's just a scheme, but normally would think you would say something that a typical Go application is something that is the way that you will write the microservice in a cloud native way. And Go is quite high performing. It's not bad at all, and it's more performant than Python, for example. But it's also so that it's not too bad to write C++ applications, and that was something that was for a long time it was sort of laughed at that you put that into containers and did your microservices like that. But from this kind of balancing energy efficiency point of view, I think it's moving more and more in this direction. And Rust is a language that we don't use that much anymore, at the moment, but it's growing, I think, in interest. And that is a very good balance, I think, with between development efficiency and energy efficiency also. So yeah, there are a whole palette of different languages here, and an important choice also when it comes to also there tackling the environmental chain questions. Cloud native developer, what's that? I hear it all the time. We need to hire tons of cloud native developers that will solve everything in the same way that Kubernetes solves everything, or moving to cloud will solve everything. And my answer is usually yeah, great if we can find good cloud native developers, but I would take a developer that is willing to learn and adopt to new ways of working and technology. I mean, that's I would take that any day. So I don't think this is the biggest problem. The biggest problem comes with the way that we need to help our customers, or we need to manage our labs, do troubleshooting of things like OpenShift or Kubernetes and so on. That's where I see that you need experience. That's something that is quite hard to gain. But if you're good at troubleshooting or as a good integrator, that's what I've seen at least. I mean, it's the same persons that get good at being cloud native troubleshooters also. So again, it's the right attitude and just the willing to learn. I think that's and again, there's so much in this that is just common sense when it comes to software development. There's a lot of principles that are way back from the 70s or something. Yeah, access to cool things and continuously improve the development environment for sure. Something that I haven't talked so much about is the increased openness also, and I think that's another benefit of moving into the cloud space and working at Ericsson, which has a history of being a quite conservative company when it comes to this. I mean, we used to do we didn't even trust to use the standard library things. We needed to implement our own vectors or whatever in some because we were unsure about how much it bloated and stuff like that. We wanted to have control. That's a long, I mean, that's a long time ago since that changed. But just moving over to Linux and instead of having maybe other real-time OSs and now for the last almost 10 years now, moving into to open source world and also not only using open source but actually being a good citizen and contributing back. I think that's a huge responsibility that I think also nice to see. And I don't mean only at Ericsson. I think this is a trend that we see on most companies, that there's an increased willingness to actually help the ecosystem, not because you think that, oh, we have great ideas and someone else will steal it now because we make it open source, but we help each other. And I think that's great. I see a lot of this in, there are huge potential when it comes to, even if you think like Kubernetes is super huge and everyone uses it, there's a lot of stupid stuff in there. So it's, I think when talking to Red Hat that is doing the OpenShift, there's a lot of things that we can, that we learn them. I mean, problems that they don't even know exist, and the workloads that they think that, but someone must have experienced this out in the world. I mean, so many users, but it feels like a lot of people are just, throwing more hardware at the problem instead of trying to fix it. And I talk about things like just the CFS, the scheduler in the default scheduler in Linux, how that will work and how that is managing the workloads that you have on your typical servers running these kind of Kubernetes clusters. Yes, it's sort of connected to where I came from in the first place. Also, that you need to focus on the application and the business logic. And if you spend too much time in the infrastructure, or you need to pay too much attention to what you're running at, how it works in different situations, so on, you probably have something that is wrong here, and you need to probably fix that in your application. But again, I just stole it from Forbes, this quote here, because it emphasized the point here. But it's I mean, it's more likely that because that's a question many companies ask: are we cloud native, or are we cloud native enough? And that is usually a bad symptom if you need to spend too much time on the infrastructure or what you're running on rather than your application logic. That could just be as true for an embedded system that didn't have any cloud native principles, I'm sure. But I think it's true in many ways. It's the application that matters. It's my final slide actually, and a sort of a collection of what I've been talking about here also. I think it makes sense, and this is something that we have done, this kind of spider diagram analysis and of different services that you want to have, or it can be your whole application, your organization, or wherever. And then you map these kind of different properties that you want to have. It could be things like feature throughput, that's super important, or the performance that we have talked about. Or if you want to be able to reuse things here, because you have different similar deployments, that might be one aspect. And smaller knockout units, for example, how elastic the system should be. And do some sort of analysis of where you are and where you want to go. And then we have some things here that might be more mapping to the environmental, or how green the software stack is. But the key here is that you need to balance here, and it's not, if you go all in, like if you're really religious about cloud native principles, there would be a number of these that you would maybe tick a box in that, but you would maybe fail miserably in others. So it's not worth anything if you go all in and be completely stateless if you're failing on some of the others. So the point is that you need to balance this, and that is something that we need to do more or less every day. And I think this is the only way to succeed, that you have this out and have it visible, and that you help out as an organization and with leaders that are maintaining this all the time. And that's things that I've been doing for a number of years at least, to try and get the sweet spot here where you get the most out of both embedded and cloud deployments. Yes.
Much. I think it was really interesting listening to. Do you have any questions? Either online, please write in the chat then, or in the audience. Take the time now.
And I will stay for some time afterwards also,
Yes.
if you don't want to take it live.
We do the microphone so people online also.
Gunnar Risberg, hi. You in the early slide you mentioned cloud and COTS hardware. How do you connect that?
Cloud and COTS hardware.
Yes.
I mean, we are using our customers, they have what they have more or less in many cases. So COTS hardware, they already have huge data centers with, and some of them are Azure based, and some are then that they manage themselves in, and very often this Red Hat Corona, if you've heard about that, the Red Hat's data center stack, that's something that is very common from telco operators, and that's, I think, because they already manage these kind of loads, and if we for telco applications that are higher up in the network, core network stuff, they have already a lot of that installed base, so they have sort of had a head start, and Red Hat is quite dominant when it comes to that kind of installations for telco applications. But it doesn't really matter. I mean, it could we can go down to Dustin and buy. We do sometimes also. we need more, and then basically any type of COTS server will do. So we don't have any. We test reference configurations and have some guiding principles for how much you can squeeze out of a certain hardware, but then it should work with basically anything.
Any more questions? Frida, do we have any questions? No. Like Anders mentioned, you will be here for a couple of minutes even afterwards, so feel free to come forward and ask questions in person as well. Thank you very much for this presentation. Next Tech Tuesday will be on the 8th of November, and then it's Combitech who will talk about value flow enabled by autonomy. And it's also part of East Sweden Innovation Week, which is the whole week, week 45, with a lot of different seminars and events happening in the region. On Thursday, it's East Sweden Innovation Day that will be held here in Mjärdevi with focus on cybersecurity. If you go to eastswedeninnovationweek.se, you have the full program, and there you also can find the registration for next Tech Tuesday, and it's also on our webpage. Thank you very much for joining us today. Hope to see you again.